Welcome everyone to today's lecture on greenhouse gas emissions, measurement and reporting. This subject sits at the heart of climate change action because, as the old saying goes, you can't manage what you don't measure. Today, we are going to go on a journey starting with the rationale for why organizations must measure emissions, moving through the global standards that define how it's done, then diving into technologies and tools that make measurement accurate, and ending with practical steps to ensure inventories don't just sit on a shelf but drive real climate action. By the end, you should feel not just informed but equipped to apply these principles in your professional work. Think of these learning outcomes as your roadmap. We begin with the why. Why does measuring emissions matter? Then we move to the how, the global standards and boundaries. After that, we explore the with what technologies, emission factors, and MRV systems. Finally, we answer the big question: so what? How do we use this data to make strategic decisions and reduce emissions? The flow mirrors the journey companies must take when setting up robust climate reporting frameworks. So imagine your organization as a ship sailing across unpredictable seas. Without measuring emissions, you are steering blind, unaware of hidden rocks or storms ahead. Measurement gives you radar. It allows you to anticipate regulatory risks, discover operational inefficiencies, and identify opportunities for innovation. Compliance may force us to measure, think EU ETS in Europe, SEC disclosures in the US, and the deeper reason is strategy. Measuring emissions uncover where energy is wasted, which processes are most carbon intensive, and where reduction can save money. And let's not forget the trust factor. Investors and customers demand transparency. The TACCC principles, which is transparency, accuracy, completeness, consistency, comparability, are not optional checkboxes. They are the credibility test. You miss one, and your numbers lose meaning, eroding trust with stakeholders. Standards are like the grammar of emissions reporting. Without them, everyone speaks a different language. The GHG Protocol is the most widely used. It tells us what belongs in Scope 1, 2, and 3. The IPCC guidelines gives us the science to calculate those emissions. ISO standards ensure we have processes in place for credible verification. IFRS S2 links emissions to finance, making carbon a material risk like currency or interest rates. CDP creates a global database for investors. By using these standards, we make sure that a ton of CO2 in Jordan means the same thing as a ton of CO2 in Japan or Germany. The comparability is what makes climate reporting powerful. Boundaries determine what's inside and outside your inventory. Organizational boundaries decide responsibility. Should we account for emissions based on ownership, financial influence, or operational control? For example, if a company owns 50% of joint venture, equity share would include half of its emissions, but operational control would include 100% if they run the operations. Then come operational boundaries, scopes 1, 2, and 3. Scope 1 is direct. Fuel burned in your boilers, emissions from your vehicles. Scope 2 is indirect, from purchased energy. Scope 3 expands outward, covering everything from the emissions of suppliers to how customers use and dispose of products. Many companies focus on scopes 1 and 2, but ignoring scope 3 often means ignoring the majority of your emissions footprint. When we talk about scope 1 emissions, we are referring to emissions that the company has direct control over. Think about the exhaust from a fleet of delivery trucks or the natural gas burned in a cement factory's kilns. These are the most visible emissions because they happen on site or in assets owned by the company. But notice that scope 1 is broader than just smokestacks. It also includes mobile combustion, your corporate fleet of vehicles, forklifts in warehouses, and even ships owned by a logistics company. Then we have process emissions, which are particularly important in sectors like cement or steel. For example, making 1 ton of cement inherently releases about 0.9 tons of CO2 due to the chemical process of calcination, regardless of the fuel used. Finally, we have fugitive emissions. These are the silent but deadly culprits. Refrigerants leaking from cooling systems or methane escaping from oil wells. They may seem small, but remember, methane has a warming potential more than 25 times that of CO2 over a century. How do companies measure scope 1? So, large facilities often install continuous emission monitoring system, which provides real-time data. Others rely on activity data, such as fuel purchased, multiplied by emission factors from authorities like IPCC or DEFRA. In industries like petrochemicals, firms use material balance methods, tracking carbon in raw material versus what leaves the process. The change: fugitive emissions are notoriously difficult to measure. CEMS, that's the one stands for Continuous Emission Monitoring Systems, equipment requires regular calibration, and fuel invoices don't always align perfectly with actual compositions data. This is why companies invest in leak detection systems, satellite methane monitoring, and infrared cameras to improve accuracy. Now let's turn to scope 2 emissions, which are deceptively tricky. These are not the emissions your company produces directly, but rather those generated on your behalf when you purchase electricity, heating, cooling, or steam. For example, if your corporate headquarters in Amman runs on electricity from the national grid, the CO2 released by the grid's power plants counts as your scope 2 emissions. If the grid burns heavy fuel oil, your footprint is higher. If it's mostly renewables, your footprint is lower. The interesting twist is in how scope 2 can be reported. There are two main approaches. First, the location-based method. This is simple. It uses the average emissions factor of the grid where your facilities are located. For instance, in Jordan, the grid still depends on natural gas and some oil. So the emission factor is relatively high compared to, say, Norway, where hydropower dominates. The market-based method is the second one, which refers to companies to reflect the actual contracts they have for energy. If you have signed a power purchase agreement for solar energy or bought renewable energy certificates, you can claim lower Scope 2 emissions. The distinction matters. A company could look very different depending on which method it uses. Apple, for example, reports very low Scope 2 emissions because it procures renewable energy contracts, even though some of its offices sit in fossil fuel heavy grids. How do we measure Scope 2? At a basic level, you take your utility bills and multiply the kilowatt hours by grid specific emission factors published by the IEA or the EPA or national regulators. For the market-based method, you instead use data from your renewable contracts. Reduction strategies are well known, upgrading to LED lighting, an efficient HVAC system, integrating on-site solar panels, and signing renewable PPA or VPPAs. More advanced companies are also using demand-side management, shifting their consumption to hours when the grid is cleaner, or using battery storage, the BSS, to offset peak demand. The challenges: grid carbon intensity can fluctuate hour by hour. Renewable energy certificates can be double counted if not tracked properly, and regulatory rules differ across regions. What counts in Europe may not count in the US. This is why energy procurement and Scope 2 accounting have become strategic issues at the boardroom level. Scope 3 is the monster hiding under the bed. For many companies, it's by far the largest part of their footprint. Think of IKEA. Their stores and trucks are important, but the real emissions come from forests being harvested for timber, factories producing textiles, and ships transporting products worldwide. For Apple, Scope 3 includes the energy consumed when millions of people charge their iPhones. For banks, it's their investments in fossil fuel heavy industries. What makes Scope 3 especially difficult is that most of these emissions occur outside the company's direct control. You can't just flip a switch in your factory or buy renewable power. Instead, it's about influencing suppliers, designing smarter products, and nudging consumers. It requires collaboration across entire value chains, which is why Scope 3 is often seen as the ultimate test of corporate climate leadership. The Greenhouse Gas Protocol gives us a roadmap for Scope 3 with 15 categories. On the upstream side, we start with purchased goods and services. Every screw, textile, or chemical you buy has an embedded carbon footprint. Then we add capital goods like machinery, the energy used in fuel supply chains and upstream transport. Even things like employee commuting or business travel fall under Scope 3. On the downstream side, we move to what happens after your product leaves the factory. Transport and distribution, how your customers use the product, and eventually how it is disposed of. For tech companies, the electricity consumed by users is massive. For FMCGs, end of life treatment like packaging waste is a hotspot. Then we have special categories like franchises and investments, which apply to global brands and financial institutions. Together, these categories show how Scope 3 forces companies to think holistically, from raw material extraction all the way to product retirement. Measuring Scope 3 is like building a puzzle without all the pieces. The spend-based method is the simplest. You take how much money you spent on something, say office furniture, and multiply by average emission factors. Quick but rough. A step up is supplier-specific data. You ask your suppliers directly for their carbon numbers. Platforms like CDP, Supply Chain, and EcoVadis are making this easier. The gold standard is Life Cycle Assessment, LCA, where you trace the footprint of a product from cradle to grave, raw material extraction, processing, use, and disposal. Once you have measured, you can act. Some of the most effective levers include requiring suppliers to set carbon reduction targets, embedding sustainability in procurement contracts, redesigning products for circularity, and optimizing logistics. For financial institutions, shifting capital towards low carbon investment is a powerful lever. In essence, Scope 3 reduction isn't just about compliance. It's about redefining business strategy for a low carbon economy. When we move from defining scopes to actually building an emissions inventory, the process rests on two pillars: activity data and emission factors. Activity data is the raw input: liters of diesels consumed, kilowatt hours of electricity purchased, kilometers flown by employees, or tons of cement produced. Emission factors then convert those numbers into CO2 equivalents. Global sources include the IPCC and national databases like the UK's DFRA or the US EPA. Some countries also provide localized emission factors that are more precise. Data can be primary, direct measurements from meters, invoices, or supplier reports, or secondary, based on estimates or generic databases. Primary is always better, but often harder to collect. Today, digital tools are transforming this field. IoT sensors can capture energy use in real time, while ERP systems can integrate procurement data directly into carbon accounting platforms. AI is also helping detect anomalies, fill data gaps, and flag double counting. Of course, there are challenges. Suppliers may report inconsistently. Some data may be missing altogether. An overlap between scopes 1, 2, and 3 can cause double counting. Navigating these requires clear protocols and governance. Once data is collected, the next big question is, according to which standard? Without a recognized framework, emissions reporting would be chaotic and incomparable. The greenhouse gas, the GHG Protocol, is the global cornerstone. It is established the concept of Scope 1, 2, and 3 emissions and provides detailed methodologies for different sectors. Nearly all corporate disclosures reference it in some way. ISO 14064 complements this by setting requirements for quantification and reporting at both organizational and project levels. It is especially useful when companies seek third-party verification. We also have the CDP, formerly the Carbon Disclosure Project, where thousands of companies voluntarily report their climate impact. Investors rely heavily on this data. The Science Based Targets Initiative, the SBTI, is about aligning reductions with climate science, ensuring companies set targets consistent with limiting warming to 1.5 Celsius. Finally, frameworks like the Task Force on Climate-Related Financial Disclosures, the TCFD, ensures that emissions reporting ties directly to financial risk transparency, which is crucial for investors and regulators alike. The big picture here is that standards bring consistency, comparability, and credibility. Without them, reporting would be meaningless, and stakeholders couldn't trust the numbers. Collecting emissions data manually is not scalable. That's why digital solutions have become central to carbon accounting. Let's start with Sphera. It's one of the most advanced sustainability management platforms, particularly for industries like chemicals, oil and gas, and heavy manufacturing. It integrates life cycle assessments, LCA, databases with GHG Protocol based reporting, making it very powerful. Enablon, owned by Wolters Kluwer, is another major player. It not only covers carbon accounting but also integrates with broader enterprise risk management. Large multinationals use it to connect sustainability with operational risks. Persephone is a newer but gaining traction quickly. It brands itself as the TurboTax for carbon accounting, providing investors grade disclosure that aligns with SEC, ISSB, and EU CSRD requirements. Then we have the SAP's Sustainability Control Tower, which is especially strong for companies already running on SAP ERP systems. It allows seamless integration of financial and emission data across complex global supply chains. Microsoft Cloud for Sustainability is also worth highlighting. It leverages IoT sensor data, AI models, and cloud dashboards to help companies visualize and reduce emission in real time. The main things to look for in these platforms are: do they cover all three scopes comprehensively? Can they automate data ingestion from IoT sensors, APIs, or utility bills? Do they allow scenario modeling? Example, what happens if we switch to renewable energy or apply an internal carbon price? And finally, do they align with leading standards, GHG Protocol, ISO 14064, CDP, SPTI to ensure credibility. In short, these tools are the bridge between raw operational data and decision-ready climate strategies. When we talk about Scope 1 emissions, we are dealing with the most tangible and immediate sources, company-owned assets and direct compositions. These are often the easiest to identify, but not always the easiest to measure with precision. One method is direct measurement. Here, the CEMS or the Continuous Emissions Monitoring Systems are installed on smokestacks or exhaust vents. They provide real-time monitoring of pollutants like the CO2, the NOx, the SO2, and particulate matter. While CEMS offer high accuracy, it's also costly, requiring maintenance and regular calibration. For smaller facilities, a more practical approach is IoT sensors and smart meters installed on boilers, furnaces, and other fuel-consuming equipment. This gives a steady flow of data without the need for full-scale SIMs. Another approach is fuel-based calculations. Here, we track the amount of fuel consumed, liters of diesel, cubic meters of natural gas, gallons of gasoline, and multiply it by published emission factors from sources like the IPCC guidelines, the USA EPA, or the UK DEFRA database. This method is less precise than direct measurement, but widely used because of its simplicity. For mobile sources, such as company-owned cars, trucks, or construction equipment, organizations increasingly rely on telematics and fleet management systems. These track fuel consumption, mileage, and operating conditions, enabling more accurate emissions calculation. Finally, one of the most overlooked areas, fugitive emissions. These are leaks from refrigeration systems, methane leaks from pipelines, or volatile gases escaping from industrial processes. Here, technologies like infrared cameras, advanced leak detection sensors, and even drones equipped with methane detectors are making monitoring more feasible. The trade-off is always between accuracy and cost. Direct monitoring with SIMS is highly accurate but expensive. Activity data calculations are cost-effective but less precise. Companies often adopt a hybrid approach, combining direct measurement where it matters the most, compliance-heavy facilities with calculation methods elsewhere. Now, let's move to Scope 2 emissions. These are the indirect emissions that result from the energy we purchase, such as electricity, steam, heating, or cooling. While we don't burn the fuel ourselves, we are responsible for the emissions generated at the power plant that supplies us. To measure Scope 2, the GHG Protocol defines two complementary accounting methods. Location-based method. This approach applies the average emissions factors for the grid in the region where consumption occurs. For example, if your office is in Amman, you would use Jordan's national electricity grid emissions factor published by the IEA or local authorities. This method gives a picture of the default carbon intensity of electricity consumed. Market-based method is the more nuanced one. It accounts for contractual instruments such as renewable energy certificates, the RECs, guarantees of origins, the GOES in Europe, or corporate power purchase agreement, the PPA or the VPPAs. If a company signs a VPPA to source wind energy, the market-based method reflects that reduced footprint, even if the grid mix is fossil heavy. Data collection for Scope 2 usually starts with utility invoices. The kWh or the MWh recorded on those invoices are multiplied by emission factors from national GHG inventories, the EPA's e-grid database in the US or the EEA database in Europe. But companies are moving towards smart meters and energy management systems, or the BAS. These provide real-time consumption data, enabling detailed carbon accounting and identifying opportunities for efficiency improvements. In many service-based industries like banks, universities, hospitals, Scope 2 emissions are often the single largest source of their carbon footprint. Unlike heavy industries, they don't burn large amounts of fuel directly, but their dependence on electricity is enormous. Therefore, managing Scope 2 is not just about reporting. It's about making strategic energy procurement choices, moving from fossil-based grid electricity to renewables through PPAs, RECs, or on-site solar panels. This is where corporate decarbonization strategies often begin. Scope 3 is often called the elephant in the room in carbon accounting. It covers all other indirect emissions across the value chain, both upstream before the company and downstream after the company. On the upstream side, think about all the raw materials and services a company purchases, like steel, cement, IT services, logistics, tangible or intangible, employee commuting, and even the fuel that suppliers burn on your behalf. For instance, if a Jordanian construction company imports steel from Turkey, the carbon emissions from smelting that steel fall under Scope 3. On the downstream side, it's about how customers use and dispose of the products. For car manufacturer, the CO2 from fuel burned by consumers driving those cars is Scope 3 under the downstream side. For a university, emissions from student travel, alumni events, and even investments in carbon-intensive industries could all fall under this category. The GHG Protocol defines 15 categories of Scope 3 emissions, ensuring nearly every aspect of an organization's activities is covered. Measuring Scope 3 is more complex than Scope 1 or Scope 2. We have three major methods. Spend-based, multiplying the amount of money spent on a category by an average emission factor. This is quick but less accurate. Supplier specific, using primary emissions data from suppliers. This requires strong collaboration and data transparency. hybrid method combines both approaches for more reliability. The challenges here are real. Suppliers may be reluctant or lack expertise to provide carbon data, and risks of double counting are high when multiple actors claim the same emissions. But here's the key insight. Scope 3 usually makes up over 70% of total corporate emissions. If we don't measure and reduce Scope 3, corporate net zero targets will never be credible. This is also where opportunities for innovation emerge. Sustainable procurement, supplier engagement programs, redesigning products for lower life cycle emissions, and pushing for circular economy models. Now that we understand the complexity of Scope 3, the natural question is, how do companies actually collect and manage this data? The answer is through specialized tools and platforms that go far beyond Excel spreadsheets. Let's start with the CDP, or the Carbon Disclosure Project. Many large corporations request their suppliers to report emissions through the CDP's supply chain questionnaires. This allows buyers to benchmark suppliers, encourage improvements, and reduce risks in their value chain. Then there is the EcoVadis, which is widely used for suppliers' ESG ratings. A company like Nestle or Unilever can screen thousands of suppliers based on their environmental performance. This helps to focus engagement efforts on high impact suppliers. For enterprise level integration, systems like Sphera or Enablon offer advanced platforms that integrate carbon data with risk management, compliance, and health safety. These are essential when reporting Scope 3 at a global corporate scale. One of the fastest growing solutions is Persephone, which provides cloud-based carbon accounting with AI-driven insights. It's sometimes called the TurboTax of carbon because it guides companies step by step from data entry to full GHG disclosure. The GHG Protocol Scope 3 evaluator tool, developed by the WRI and Qantas, is another free but powerful resource. It is especially useful for companies at the early stage of Scope 3 measurement. A growing trend is the integration of carbon accounting into the ERP systems like SAP and Oracle. This means emission data is linked directly to procurement, finance, and logistics operation. Finally, blockchain and AI innovations are emerging to improve transparency and prevent double counting. Imagine a blockchain ledger that records every carbon-intensive activity across the supply chain, from raw material extraction to customer use, with immutable timestamps. This is where carbon accounting is heading. The benefits of using these tools are clear: better accuracy, increased supplier engagement, automated data flows, and audit-ready reports that meet compliance with the standards like ISSB, CSRD, or SEC rules. In other words, the future of Scope 3 measurement will rely on technology ecosystems rather than fragmented spreadsheets. Scope 1 is where companies have the most control because it deals with emissions from assets they directly own and operate. The first lever is fuel switching. Historically, firms moved from coal to natural gas to reduce CO2. But the new frontier is moving to green hydrogen, biogas, or synthetic fuels. For instance, steel plants in Sweden are piloting hydrogen based furnaces to replace coal in blast furnaces. The second lever is electrification of fleets and industrial assets. Transitioning delivery trucks, that's the one used in Amazon, for example, company cars, and even mining equipment to electric alternatives can reduce Scope 1 significantly, especially if powered by clean electricity. Another hidden but critical source of Scope 1 is fugitive emissions, leaks from pipelines, valves, and compressors. Methane leaks are a massive problem in oil and gas, and leak detection with infrared cameras or drones has become a game changer. Repair programs can reduce emissions dramatically at relatively low cost. Then there's carbon capture, utilization, and storage, the CCUS. While still expensive, the CCUS is becoming essential for hard to abate industries like cement and petrochemicals. Captured CO2 can either be stored underground in geological formations or used to create synthetic fuels and construction materials. Finally, operational efficiency is often overlooked but vital. Techniques like heat recovery, advanced process controls, and AI driven optimization can shave emissions by reducing energy waste. In short, Scope 1 mitigation is about rethinking the inputs and processes of production itself. Scope 2 relates to purchased electricity, steam, heating, and cooling. These are indirect emissions, but typically make up a large chunk of a company's footprint. The most direct solution is on-site renewables. Many firms are installing rooftop solar and small-scale wind to meet part of their electricity demand. This also builds energy independence and resilience. The second lever is power purchase agreements, the PPAs, or virtual PPAs, the VPPAs. These are long-term financial contracts with renewable energy developers that allow companies to claim the renewable attributes of clean electricity. For example, Amazon and Microsoft both use VPPAs to meet their 100% renewable electricity targets. Another cost-effective strategy is energy efficiency retrofits. From upgrading to LED lighting and smart HVAC systems to deploying building automation and IoT sensors that continuously optimize energy use. For companies that cannot install renewables directly, they can buy renewable energy certificates or the RECs or guarantee of origins in Europe, depending on the market. These certificates provide proof that electricity equivalent to their consumption was generated from renewable sources. Finally, advanced companies used demand-side management strategies. By shifting operations to off-peak times, storing energy in batteries in the ESS system, or participating in smart grid programs, firms reduce both emissions and costs. Scope 2 is often called the low-hanging fruit because solutions are commercially mature and the business case is clear. Scope 3 is the most complex and largest share of corporate emissions. It includes everything from the raw materials a company buys to the way consumers use and dispose of its products. The first lever is supplier engagement. Multinationals like Apple or Unilever now require suppliers to disclose emission data and commit to renewable energy use. Many even co-invest in supplier clean energy projects. Another major lever is product redesign by embracing circular economy principles like the ones being used by Amazon when they redesign their packaging system and reduce the airspace inside their packages, such as designing products to be recyclable, reusable, or lighter. Companies reduce emissions across the value chain. A good example is Adidas producing shoes made entirely from ocean plastic that can be fully recycled. Sustainable logistics also plays a big role. Firms are shifting to electric delivery fleets, Amazon, experimenting with hydrogen-powered shipping and using AI for route optimization to cut fuel waste. But Scope 3 doesn't stop at the supply chain. It extends to consumers. Companies are increasingly turning to eco-labels, carbon footprint disclosures, and incentives for recycling and to influence customer behavior. Think of Nestle adding carbon labels to its coffee products to encourage climate-aware purchasing. Finally, no company can add Scope 3 alone. Industry alliances like Science-Based Targets Initiatives, the SBTI, and sectoral climate commitments create shared pathways and allow collaboration with competitors, suppliers, and policymakers. Scope 3 mitigation is a story of collaboration and system change, not just internal action. So, after discussing mitigations, we must consider how companies measure, verify, and disclose their emissions and climate risks. This is where global standards and frameworks come into play. The GHG Protocol remains the backbone. It provides the methodology for calculating Scope 1, 2, and 3 emissions. Almost every other framework builds on it, making it common language of carbon accounting. The ISO standard adds rigor. The ISO 14064 offers verification frameworks for GHG reporting, while the ISO 5001 sets standard for energy management system, helping companies systematically reduce energy-related emissions. Recently, the ISSB, the International Sustainability Standards Board, has emerged under the IFRS. Its S1 and S2 standards set a global baseline for sustainability and climate disclosure with a strong momentum for global adoption. In Europe, the Corporate Sustainability Reporting Directive is a game changer. Starting 2024, thousands of companies operating in or doing business with the EU must provide detailed sustainability disclosures aligned with the EU taxonomy. This covers not just emissions but biodiversity, pollution, and social governance aspects. Meanwhile, in the United States, the SEC has proposed climate disclosure rules requiring listed companies to report climate risks and Scope 1 to 3 emissions if material. This represents a huge shift towards mandatory climate transparency. Finally, many of these frameworks align with the Task Force Climate-Related Financial Disclosure, the TCFD, which emphasizes reporting on governance, strategy, risk management, and metrics. Importantly, the TCFD also requires scenario analysis, assessing how a company performs under the 1.5 Celsius or 2 Celsius climate futures. The key takeaway, while there are many acronyms, the trend is convergence. Regulators, investors, and consumers increasingly demand comparable, auditable, and decision useful climate data. In practice, companies must design systems that can simultaneously comply with multiple frameworks while building investor confidence. As we conclude, let's reflect on why measuring and reporting carbon emission is not just about compliance. It is about long-term survival and competitiveness. For investors' confidence, today, global investors rely heavily on ESG ratings and climate disclosures to guide capital flows. Companies with transparent, verifiable emission data are rewarded with better access to financing, while opaque firms risk divestment. BlackRock, for example, has made it clear that climate risk is investment risk. Second, risk pricing. Banks and insurers are incorporating climate transition risks into their models. If your company operates in a carbon-intensive sector and lacks a clear reduction strategy, you may face higher borrowing costs, higher insurance premiums, or outright exclusion from portfolios. Third, carbon markets. Firms that measure emissions accurately can tap into carbon offset projects and even generate new revenue by selling credits. Under Article 6 of the Paris Agreement, international carbon trading is expanding rapidly, creating a new incentive for robust emissions inventories. Fourth, a competitive advantage. Multinationals like Amazon, Apple, Microsoft, Google demand emissions data from their suppliers. If you want to stay in their supply chain, you need to report and reduce. This shifts carbon from nice to have to a business continuity requirement. Fifth, regulatory readiness. With the EU's Carbon Border Adjustment Mechanism, the CBAM, carbon-intensive imports face tariffs unless companies disclose and decarbonize. This directly affects exporters in steel, cement, and other industries. Failing to prepare means losing entire markets. Finally, efficiency and resilience. By tracking and reducing emissions, companies discover cost-saving opportunities in energy efficiency, logistics optimization, and waste reduction. In an era of volatile energy prices and supply chain shocks, those gains can be decisive. This big message, carbon accounting is becoming as central as financial accounting. Companies that embrace it gain capital, resilience, and reputation. Those that don't will face rising costs, shrinking markets, and reputational damage. As we wrap up, remember that the journey from measurement to mitigation to disclosure is not linear. It is a continuous cycle of improvement. The firms that internalize this cycle will thrive in a low carbon future. I would like to share with you this table, which shows the MRV, the monitoring, reporting, verification matures across scopes. I try to bring them all in one single place to be as kind of a reference for you in the future. So scope 1 starts with manual tracking of fuel bills, but leading firms are moving toward IoT and satellite-based methane monitoring, which regulates like the EU are encouraging. Scope 2 progresses from just collecting invoices to granular time of use monitoring and eventually blockchain-enabled renewable energy certificates, ensuring transparency in green energy claims. Scope 2 is the hardest. Many firms begin with rough spend-based estimates, then advanced it to LCA database, and finally into AI-driven supplier-specific accounting with blockchain traceability. Verification also matures. Internal checks, consultants, full ISO, the CSRD, SEC level assurance. This structures let stakeholders see the pathway from compliance to leadership in a carbon disclosure. As we move to the very last slide of our intense lecture, let's step back and highlight the big takeaways. First, carbon accounting is no longer optional. It is becoming as essential as financial accounting. Just a balance sheet and cash flow statement determine corporate credibility. Emissions reporting is now a key indicator of resilience and responsibility. Second, understanding scope 1, 2, and 3 emissions is fundamental. Scope 1 covers what we burn directly. Scope 2 captures what we purchase. Scope 3 extends to the full value chain, often the largest and most complex share of a company's footprint. Together, they define the organization's climate accountability. Third, measurement and reporting are not just regulatory exercise. They build trust with investors, lenders, and insurers, and help firms stay competitive as ESG ratings and supply chain standards rise in importance. Fourth, mitigation strategies vary by scope, but whether it's efficiency improvements, renewable energy procurement, or supply chain engagement, each strategy drives innovation, lowers cost, and strengthens resilience. Fifth, transparency is power. In global markets, companies that disclose emissions proactively and credibly are rewarded with partnerships, preferential financing, and reputational gains, while laggards face penalties, tariffs, and exclusion. Finally, the broader point, future proofing is leadership. Firms that start today will not only reduce risk, but also position themselves as industry leaders in a low carbon future. The overarching message is this: carbon management is both a responsibility and an opportunity. It's about compliance, yes, but also about vision, shaping resilient organizations that thrive in the decades to come. Thank you very much for attending 1 hour lecture on the most important measuring in monitoring and reporting and reducing the GHG emissions. This is Dr. Zeadat from Jordan, and I wish you all the best in your endeavor. I hope that you have benefited from my lecture, and hope to see you again in another lectures.